Okay, for this lesson we're going to learn about probability, and here's our introduction to probability. As I go through the notes, I expect that you are copying down any terms that go into the blanks and then filling in your notes as we go, as well as any examples that we do. So starting with probability, what is probability? Probability is a number from 1 to 0, which means it can be written as a decimal, as a fraction, or as a percent, that measures the likelihood or chance that an event will occur. So again, right now you should be copying in your words, chance and occur. Whether or not you write it as a fraction, decimal, or percent will really depend on the question. Most of the time you'll write it as a fraction, but then just make sure that you are doing it in the way that it's presented to you. Or if it asks what is the percent, then obviously you answer in percentages. An outcome is the possible result of an experiment. So if you're rolling a dice, your outcomes are a 1, 2, 3, 4, or 5, or 6. So all of those, you have 6 possible outcomes. The next word is event. The event is the actual outcome or collection of outcomes. So rolling an odd number, if that's what you're looking for the event for that to occur. And I'll show you an example of that in a minute. And then sample space is the set of all possible outcomes. So back to the dice example, the set of all possible outcomes when you roll one dice or a die, it would be 1, 2, 3, 4, 5, and 6. So there's 6 numbers that would be in your sample set or your sample space. So now if we look at probability of an event. Over to the side you see it says P parentheses event. That word event is not going to be given to you when you're looking at the probability. It'll have that capital P, and then in that parentheses it will have what you're wanting to occur. So again, if we go back to the dice example, if we're wanting to roll an odd number, it would be P parentheses odd number. So what's the probability of rolling an odd number? So the way that we're going to write that will be as a fraction. It's going to be the probability of whatever the event is going to be the number of outcomes or number of favorable outcomes. And I'll put that here over the possible outcomes. So again, you think about, if we're trying, again, in the example I was speaking of, rolling an odd number, there would be number 1, 3, and 5 if you're rolling one die. So there'd be 3 favorable outcomes over a 6-sided number cube would be over 6. So it would be 3 over 6, and then you would reduce it. Then notice it does give you a little bit more information. Probabilities are expressed as numbers between 0 and 1. We already discussed that. The closer the probability is to 1, the more likely the event is to happen. The sum of all possible outcomes is 1. Remember, the number 1 is the same thing as 100%, so that might help you to think about this, is that if you're looking at this adding up all possible outcomes, then it should sum or add up to be 1, because that would be 100% of the possible outcomes. Alright, so let's go to this graphic right here. If we're describing probabilities, I already mentioned it when we first talked about it had to be a number between 0 to 1. It can be written as a fraction, a decimal, or a percent. Notice that the number line that's being given to you is given it to you in fraction form. And if we're looking at 0, if we have that the probability of an event is 0, that that means that it is impossible. It will not occur. So again, back to a number cube. If I was rolling a number cube and I was looking for the probability of rolling a 7, that's not possible, so it would be 0% chance that it would happen, or it'd be 0. The next one, we're looking at 1/4. 1/4 is pretty close to that 0. That means that if something has like a 25% chance of occurring, it's unlikely. Like on a multiple choice test, you have 4 options. If you have no clue what an answer is and you just choose one of the 4, it's unlikely that you're going to choose the correct answer. It's more likely than choosing nothing, but it's unlikely because you're choosing 1 out of 4. In that same case, what if we narrowed that multiple choice down to you marked out 2 answers and you have 2 left? Then that would be 1 out of 2 chance, which means that it's equally as likely. Or if it's a true-false question, you only have 2 options, therefore it's an equally as likely chance for you to choose the correct answer. Now if we're looking at 3/4, that would be a likely event. If we have something that's 75% chance of accuracy, then that means it's likely to happen. Or if you have like a 75% chance of rain, which is the same thing as 3/4, that means that it's likely to rain. It's more likely to rain than not to rain. And then if you have the number 1, remember 1 means the same thing as 100%. That means it is certain. It will definitely happen. Like if you're rolling back to the number cube, if it's rolling a number cube and the event you're looking for is rolling a number less than 10, it's going to happen because every number on one number cube is less than 10. Alright, so let's look at some examples down here. We determine the likelihood of something occurring. And that's, again, if we're looking at a fair number cube. We're saying fair, that means that it's not likely to, more likely to roll like a 1 than it is a 6. So first one is probability of rolling a 2. So think about how many, if you look up here, the number of favorable outcomes, how many 2's are there on the number cube? There's only 1 2. And what's our total possible outcomes? Are numbers 1, 2, 3, 4, 5, and 6. So that's out of our 6 outcomes. So now think about it. Where would 1/6 fall on this line? 1/6 would probably be right around here because it's a little bit less than 1/4. So that would be unlikely. Now let's go to the one beside it. Probability of rolling an odd number. If we think of our odd numbers, it's numbers 1, 3, and 5. So we have 3 odd numbers over our 6 total, which reduces down to 1/2. 1/2 is right there on our chart above, so this means it's equally as likely. So we have a 50-50 chance of rolling an odd number. Alright, the next one, rolling at least a 5. Now this is thinking back to our inequalities that we dealt with a couple of lessons or a couple of units ago. At least a 5 means that the numbers 5 and 6 would be favorable outcomes. So that's 2 out of our 6 outcomes. That reduces down to 1/3, and remember 1/3 is 33%. So that would be somewhere between unlikely and equally as likely. It's closer to unlikely. I'd put it's not very likely. Because 33% is closer to 25% than it is to 50%. Alright, rolling an integer. Think of our outcomes are the numbers 1, 2, 3, 4, 5, and 6. all of them are integers. So all of our integers all of our numbers possible are here. So we have 6 out of our 6 numbers are integers, which means 1, which means it will certainly occur. Next one, rolling less than 3. Our numbers that are less than 3 are 1 and 2, which would be 2 out of our 6 outcomes. Reduces down to 1/3, and again, that's the same fraction that we had here. It's not very likely. And our last one, probability of rolling a negative number. This cannot occur, so it'll be 0 out of 6 possibility, which means that our probability would be 0, which means it's impossible. We cannot roll a negative number on a regular number cube. Okay, so let's look at these word problems. As I go through it, I will cure the word problem. There are 3 choices of soda: Coke, Sprite, and Dr. Pepper. The probability of getting a Coke is 3/10. Probability of Sprite is 1/5. Find the probability of getting a Dr. Pepper. So that's what I'm going to circle. Alright, when I think about this, I want to make sure I take note that all of these should add up to 1. Also, I'm given fractions that don't have the same denominator. But if I have 3/10 and I'm trying to add that to 1/5, I can just change 1/5 into something with a 1/10. That would be 3/10 plus, if I multiply this by 2 and this by 2, I'll get 2/10. And that gives me 5/10. So right now, 5/10, or also can be written as half, is either Coke or Sprite. So that's Coke and Sprite together give me half of the possible answers. So the probability of getting Dr. Pepper is what plus that 1/2 gives me 1 whole, which is our total possible outcomes. What plus half gives me a whole will be half. So half of your drinks will be Dr. Pepper. Here I didn't go through the steps of actually solving this equation because you should know that half plus half equals 1 whole, but if you did need to go through that, you could have subtracted half from both sides and you would have had 1 minus a half, which would leave us with a half, and again x would equal half, which is how much Dr. Pepper we would have. Alright, on to our second example. You sold the most for the school's fundraiser, so you get the entire cash vault, or enter the cash vault. There are 1, 5, 10, and $20 bills. The probability of picking a 1 is 48%. Probability of picking 2 is 26%, and a $20 or of a $5 bill is 26%. $20 bill is 10%. What's the probability of picking a $10 bill? So basically we need to add up. We have 48, 26, and 10. And we want all of these to add up to be 100%. So add these together. And you get that these equal a total of 84%. So what's left over is going to be our percentage of $10 bills. So our $10 bills is what percentage of $10 bills is what I'm calling X, plus that 84% will give me that 100% total. Subtract 84% from both sides, and you end up with X equaling 16%. So there's 16%, or let's just write it as $10 bill is 16%. So it's in the same terminology that was given up here. So $10 bill is 16% of the dollars in there. Alright, so turn over to the back side of your page. And let's look at the next set of notes that goes along with this. And it starts with theoretical and experimental probability. Theoretical and experimental probability is two different types of probability that are kind of opposite of each other. Theoretical is based on knowing and calculating all of the equally likely outcomes of an experiment. Basically, it's what should happen. So what we were just looking at with all of our examples on the other side of this page was theoretical probability. Those are what should happen. And that's where it's the number of favorable outcomes over the possible number of outcomes. Experimental probability is a little bit differently. That's when you're actually conducting an experiment, and it's what does occur when you're conducting that. So it's based on an actual repeated trials of an experiment. So it's what actually happens. So in experimental, that's when you actually conduct your experiment, collect the data, and then the probability of whatever event you're looking for is the number of outcomes that occurred over the number of trials performed. And right now I know this is just a bunch of words, and that we'll end up looking at examples of each. So right now theoretical, just overall we know is what should happen. Like if we're rolling a dice, we know that we should get 1 out of every 6 rolls be the number 1. Or if you're flipping a coin, 1 out of every 2 is heads. You should, if you rolled it 10 times, you technically should end up with 5 heads, 5 tails. So that's theoretical. Experimental is what actually happens. So if you flip a coin, what is the theoretical probability that you land on heads? So that's the probability of heads should equal 1 out of 2, because we have 1 head on a coin, one side's heads, one side's tails, and so there's 2 possible outcomes, either heads or tails, and we have 1 out of those 2 is, and it actually asked for tails, so this should have been tails, but it's the same probability. Alright, if a coin is flipped 20 times, how often should you land on tails? So half of 20 gives us how many times we should land on tails. That would be, we should land on tails 10 times. So again, you just took your probability of tails and multiplied it by the number of occurrences, which was 20, and that's how we got that it should occur 10 times. Alright, so let's look at the experimental probability example that was given. Below are the results of choosing a card from a deck of cards, resulting or recording the suit and then replacing the card. So you put the card back in the deck after you picked it. So they drew 6 hearts, 10 diamonds, 7 clubs, and 5 spades. What's the probability of choosing diamonds? So first thing you need to know is how many total times was cards chosen. It wasn't given to us here, so we have to look at our data. It was chosen 6 plus 10 plus 7 plus 5. So you need to add those up. 6 plus 10 is 16. 16 plus 7 is 23. 23 plus 5 is 28. So we're looking for the probability of diamonds. We chose 28 times. And then you come up to what occurred in our experiment. 10 out of our 28 cards that were chosen were diamonds. We do need to reduce this. The number that goes into both 10 and 28 is 2. 10 divided by 2 is 5, and 28 divided by 2 is 14. So the probability of diamonds is 5 out of every 14 cards will be a diamond. Alright, now let's look at the two examples that are given and have to determine whether or not they're theoretical or experimental. Again, theoretical is what should occur. Experimental is what happened when someone actually conducted an experiment. I rolled the die 30 times and it landed with a 6 face up 10 times. Again, it already has told you that I rolled the die. That means that it is an experiment. Because a trial, or it tells you that 6 times a 10 came up out of the 30 times, that was a trial. Alright, so if we're looking at this one, 16 airheads are in a bag, 4 are cherry, 7 are orange, 5 are apple. The probability of picking a cherry is 1/4. So let's look at that. If we have cherry, which is 4 cherry, over the 16 total airheads that are in the bag, that gives me 1/4. That means that is theoretical. Yes, it is definitely possible that if you chose candy out of the bag 16 times, replacing it each time, that you may actually choose 4 cherry out of the 16, but this is just theoretical. It didn't mention anything about an experiment occurring. So what I want you to do is right now, you're going to get a chance to roll a dice 20 times and record your trials. So every time you roll a 1, you record a 1. Just do your tally marks. You're going to just do tally marks for these. So do that 20 times and record your tally marks. Then over here, use the information from the experiment for questions 1 through 5. So you're going to come over here, you're going to say probability of rolling a 4, theoretical, what should it be, and then what actually occurred in my experiment. Probability of an even number, theoretically, what should that be, and then what happened in my experiment. So think about your even numbers. And then probability of a factor of 3. Remember, factors are going to be the numbers that divide evenly into 3. Do not confuse it with multiples. And theoretically, what should it be? And experimental, what should it be? Oh, theoretical is what should it be, and experimental, what actually happened in your event. Then answer questions 4 and 5, looking back at this information that you filled in over here. And then the last part, you're going to try to answer questions number 6, 7, and 8. We will go over this in class tomorrow, and you will be given a homework sheet to do as well. So go ahead, do this part, show the teacher, and then once you're finished with that, you will receive your homework to start working on.